Hello students, welcome to topic 7b notes, section 7.6, factoring ax squared plus bx plus c. Walk you through the warm-up. So in the first one, we are just going to use the distributive property. So 8 times 5 is 40, and x times x is x squared. Then we have 8x times 3, which is 24x. We have 5 times 5 is 25x, and 5 times 3 is 15. And we're going to combine everything that we can. So our like terms here are 24 and 25x, which is 49x. All right, in the next one, we will distribute v times 7v, which is 7v squared. V times 2 is 2v. Negative 3 times 7 gives you your negative 21v. And then negative 3 times negative 2 is negative 6. And we can combine these two items because they're like terms. So 7v squared minus 19v minus 6. And if at any time this is going too fast, you can slow it down or pause it. Next thing we'll do is complete the following factor sum table for 12 and negative 12. So here's our first example. 1 times 12 is 12. So those are our two factors. Added together, they equal 13. That's our sum. So our next one we can do is 2 times 6, which is 12. And those together add up to 8. So next one, what times what? We can do 3 times 4. That's our last set of factors. 3 times 4 is still 12, but it adds up to 7. We can go in the negative direction with all of these. So negative 1 times negative 12 is a positive 12. Still gives us the 12 we're looking for. But negative 12 minus 12 is negative 13. Then we have negative 2 times negative 6, which multiplies to negative 12 but adds to negative 8. Lastly, we have negative 3 times negative 4. Negative 3 minus 4 is negative 7. They sum up to negative 7. Okay, next table, we want everything to multiply to negative 12. This one's a little bit different. So we're going to do 1 times negative 12, which will be, here, let's just do the factors. 2 times negative 6. 3 times negative 4. Those all multiply to negative 12. Then we have negative 1 times 12. We flip everything around. And we'll get negative 2 times 6. We'll get negative 3 times a positive 4. Those are all possible. Notice these are all positive and these are all negative. These are all negative and these are all positive. And what do they add up to? That's the question here. These are a little bit different. 1 minus 12 is negative 11. 2 minus 6 is negative 4. 3 minus 4 is negative 1. Negative 1 plus 12, or 12 minus 1 is 11. 6 minus 2 is 4. And then 4, negative 3, and 4 is our 1, which I left here as well. So what you notice is that you have the negative 11, negative 4, negative 1 as sums, or 11, 4, and 1 as sums, versus 13, 8, and 7, and negative 13, negative 8, negative 7. So think about if 12 or negative 12, these factors, think about if we were to end with a 12 or a negative 12, look at all the possible factors we can use to make them up. I mean, there's 12 different options here, which is quite a bit. So they sum positive and negative 13, 8, 7, or 11, 4, and 1, or negative 11, negative 4, negative 1. So today we're talking about factoring. We're going to go, instead of going from the distributive property down to our polynomial, we're going to be given a polynomial, and the goal is going to be to go backwards and factor it, which is what this looks like. So here we have a trinomial, and we can factor it back into this set of binomials. So here's one binomial, here's another binomial. And that's what our goal today is to do. So we'll be able to factor a quadratic trinomial when a is not 1. And we're going to do that by factor by grouping. We have a quick factor by grouping. We have a little bit more complicated factor by grouping. We also will be able to factor out a greatest common factor before even factoring it further. So we'll look at all three of those examples. So first example we have here is considering the product of this. So let's distribute this, and then we'll go back and factor it. So the goal is that we're going to go in one direction by multiplying this together. So 6x squared plus 3x plus 8x plus 4. So we now have it distributed, and I'm going to clean it up by combining like terms. So it looks like our 3x and 8x can become 11x. So right now, the goal isn't to get to this spot right here. It's not to get our trinomial. It's actually to take our trinomial and get it back to look like this binomial. So there's two methods we're going to talk about today. And one is the factor by grouping. And then I have a special method that a few other math teachers use that's a quick factoring by grouping. So I'll call it traditional factoring by grouping or quick factoring by grouping. And I'll show you both right now. Alrighty, so now we're going to look at factoring by grouping or traditional factoring by grouping. And quick factoring by grouping. All right, so for factoring by grouping, we are going to take this 6x squared plus 11x plus 4, and we are going to break this down. Imagine that we didn't already know that 3x plus 4 times 2x plus 1, both of those binomials, would actually result in this. Well, the way that factoring by grouping works is we need to split up the 11x so we can then factor out of it. So let me explain. The first thing we're going to do is take our 6 and our 4 and multiply them together. It's called multiplying a times c. So 6 times 4 is 24. So what numbers of 24 add up to 11? Because what we could do is we could break 11 into 1 and 11, 2 and, I apologize, 1 and 10, 2 and 9, 3 and 8 in terms of addition, right? And the way to factor this, though, a quick way is getting this 11 to somehow match up with this 24. So do a times c, we get 24, and then immediately we start to think, well, hey, I could break that into 3 and 8, and that's what I need to do to my middle term to break, I need to break that apart so that I can then factor this by grouping. So let's take 6x squared, and then we'll do plus 3x plus 8x plus 4. So you start to notice it's kind of going back to exactly what I already had right here. But the way I didn't know this initially, assume I didn't know this initially, and I was just given the end result of the polynomial. So I have 3 and 8, I separate them, and then I am going to factor them. So I'm going to factor out from this one what I see in common, which is a 3x. And when I factor out a 3x, I have a resulting 2x plus 1. So 3x times 2x is 6x squared, and 3x times 1 is 3x. So Then I'm going to do the same thing with these terms. I'm going to factor out what I see as a greatest common factor, which not 2, is a 4. And that leaves me with x, I apologize, 2x plus 1. And immediately you see that this now is a term and this is a term, but they have the same 2x plus 1 in common. And that's exactly what I wanted, because now that they're now that these two terms kind of look like one term and these two terms kind of look like one term, I can now factor what they both have in common, which is the 2x plus 1 out of it again. So I'm going to factor out the 2x plus 1, and that leaves me with what's left over. So get rid of that, and I have 3x plus 4. And I don't want to leave that slash through it. Whoops, let me change that. That was just a visual to show you that that's being factored out, and that what's left over is 3x plus 4. And that's factored by grouping. Now, you say, well, Mr. Wright, what if instead of 3 and 8, I did 8 and 3? Don't worry, it's going to work out. I'm going to duplicate. Let me duplicate all of it. Well, let me move this over and move this over. And I'm going to duplicate it and show you that the order doesn't matter of how you arrange those. You still would have had 3 and 8. Let's move them around. So let's do 8 and 3. Because let's say you broke it into 8 and 3. Well, that does change this factor. So let me get rid of all of that. And when I factor 6x squared plus 8x, I can now only take out a 2. Yep, a 2x, which leaves me with 3x plus 4. And in the second set, I can only factor out a 1. That's as far as I can go, which still leaves me with 3x plus 4, because 1 times anything is itself. Now, they both have 3x plus 4 in common, so I factor out 3x plus 4. Most likely, I would have put this term first now, and what I have left over is 2x plus 1. So we notice in both of these cases that it doesn't matter 3 and 8 or 8 and 3. We simply are able to break this middle term apart, separate them, factor out what we have in common, and then we get to the point where we can factor it out again. It's a double factor to get to our final result. Now, I have a method, whether or not you're able to use it in other, in other classes in the future, at least it's a way of checking your work. So I'm going to call this quick factor by grouping. And what I like about this method is, and I realized it when I was in high school, that there's a quicker way to do this. It's pretty foolproof as well. I call it quick factor by grouping. You're going to do the same exact thing. You're going to do A times C. So we're going to do A times C. And A times C is going to be 6 times 4, which is 24. Whoops. The difference, well, there's no difference. We're going to break it into 8 and 3. Because 8 and 3 add up to the 11 that you're looking for. Here's the difference. Instead of breaking the 8 and 3 up this way and factoring again, that's quite a bit of work. You can do your factoring right here. Let's take our 6. You then take A and you introduce A back in. So the factors of A, well, you can't divide 8 by 6 and 3 by 1, right? 6 times 1 is 6. Well, that's not going to break up nicely. You also can't do 3 and 2. That's a disaster, right? This leaves us with some decimals. But you know what works out really nicely? The factors of A. So factor of A could be, I don't know, 3 and 2. And when I go to introduce that, the 3 goes here nicely, and the 2 goes here nicely. What I'm doing is I'm doing the factoring part So 8 divided by 2 is 4, and 3 divided by 3 is 1. I'm doing the factoring part to find out the 4 and the 1. They're both positive, too. And from that 4 and 1, the question is, how do I get 4? Well, 8 divided by 2 is 4, so 4 times 2 is 8. So the only way to get 4 and 2 to work, the 2x cannot go here. The 2x has to go here in the left binomial for it to multiply over to be a part of the right binomial, and vice versa. The only way to get 3 and 1 is if the 1's in the left, the 3x has to be in the right. So we're done. The question, it's kind of like you're looking diagonally here. It's like you're like, okay, 4 and 3 have to match, and 2 and 1 have to match. It's just taking the factors of A and C, multiplying them together, breaking them apart to get 11. But again, 11 has to work out with the A. If you put a 6 here and you multiply it by 4, you're already at 24x. You're way, way, way too high. You put the 6x here and you multiply it by 1, you're only at 6x. Well, you only have 1 left over. 1 times 4 is 4. 6 and 4 is 10. You're not at where you need to be. So it's reintroducing the A factor back in, and then looking at the diagonals here to see 2 times 1. So 2 has to multiply 4 to get 8. So 2 and 4 have to be in separate places, meaning that 2 and 1 are paired and 3 and 4 are paired in their binomial. I know this is a lot, so we're going to do a couple more practice problems, and then I'm going to let you do your practice. So here, factoring a trinomial, we'll do it the traditional way and the quick way. So again, let's take our 3x squared. So we have 3x squared minus 2x minus 8. And I'm going to do factor by grouping on the left-hand side. So I'm going to do a times c. So I'm going to do a times c, which is 3 times negative 8, which is negative 24. Whoops, let me clean that up. Negative 24. I'm going to ask myself, what factors of negative 24 add up to negative 2? 1 times 24, 2 times 12, 3 times 8. We're still not at the negative 2. That's too far away. 4 times 6. Ooh, 4 and 6. Let's do a positive 4 and a negative 6. 4 minus 6 is negative 2. 4 times negative 6 is negative 24, which is what 3 times the negative 8 is. So 4 and negative 6 are exactly what I need. So I'll break this into 3x squared plus 4x minus 6x minus 8. Remember, you can interchange this. 4 and 6, when you do factor by grouping the traditional way, you don't need to worry about how they're placed. The 4 and the negative 6 could switch positions if we wanted. So here I'll factor out what's in common, which is x, which leaves me with 3x plus 4. And here I'll factor out what's common, which is 2. However, if I factor out a 2, so hold on, don't write anything. If I factor out a 2, I'm left with negative 3x minus 4. That doesn't match. So don't factor out a 2. Instead, factor out a negative 2. And I now have the 3x plus 4, both being positive. Because negative 6 divided by negative 2 is positive 3, and negative 8 divided by negative 2 is positive 4. Now, factor it again, factor out what's common, 3x plus 4, and x minus 2 is left over. And we're done. You can always distribute everything back together to check your work. In an effort to save time on this video, I'm not going to do that. I do want to save your time. So how do I do this by factor? By grouping? Well, literally the same thing's going to happen, okay? So I'm going to multiply a times c, and a times c is 3 times negative 8, which is going to give me negative 24, and I still need to get that to be a negative 2. But now what I need to do is reintroduce the 3 back in. So a is 3, which I'm going to break into 3 and 1. Those are the only factors I can break it into, is 3 and 1. So here's quick factor by grouping, 3 and 1. So introduce the a back in right about here, 3 and 1. Well, 3 wouldn't go here. That wouldn't work out. Instead, I'll divide this by 3 and this by 1, which gives me a 4 and a negative 2. Voila. To get a negative 6 and a positive 4, I have to put my 4 and my negative 2 in its place. So put it wherever you want, 4 and negative 2. But the only way to get negative 2 is to have 3 multiply it to get the negative 6. So that puts 3 in this side, right? Because 3 times negative 2 is negative 6, and then 4 times 1x is going to be the positive 4 that we want. Notice 3x plus 4, 3x plus 4, 1x minus 2, 1x minus 2. Again, super quick, just the work is done here instead of within this first factor. I'm going to show you another example. I'll let you do these on your own in an effort to save time for the video, but I will post the published notes of this, okay? And maybe I'll do one more. How many more examples do we have? Yeah, let me do one more. Okay, I will do, let's do some with negatives. Yeah, let's get this one with the negatives here. Yeah, this one should be good. So I'm going to factor, let me first write 2x squared minus x minus 6. And I will do a times c, which is going to be 2 times negative 6, which is negative 12. Now I need factors to add up to a negative 1 here. So I'm breaking into, how about 3 and negative 4? That will work out well. So breaking into 2x squared plus 3x minus 4x minus 6. So I'm breaking the negative x into 3x minus 4x, which is your negative 1x. Then we have negative 6. So I'm going to factor out what I know from here, which is literally only x. Now, if you switch these, you might have got you're going to get a different result. But here we factor out an x. And then here I'm going to factor out a negative 2. And in both cases, I get 2x plus 3. That is supposed to happen. And now I'm going to factor out the 2x plus 3. And what's left over is x minus 2. And that was the quick method, but I am now going to do the factor by grouping method. So watch quickly on this one. I'm still going to do a times c. So a times c is I'll just do it out. So 2 times negative 6, which is negative 12. I still break it into 4. I apologize. I don't know why I did that. I'll break it into 3 and negative 4. And you know what, that's why I'm a little bit, okay. Now I need to reintroduce the a back in. So a is 2, and 2 only has factors 2 and 1. So 2 and 1 need to show up here. 2 works very nicely here. You're just looking to find out what works nicely. Obviously, if I put 2 here, 3 divided by 2 is 1.5, and I don't want any decimals. So you're always putting the 2 and the 1 in spots that work nicely. You're always putting them in spots that work nicely. So now what I have left is I have 3 and -2. So 3 and -2 are my resulting second part of my binomials, just constant terms. And then the question is, how do I get -4? Well, that's only going to happen if 2 multiplies -2. So 2x has to go here, and then your 1 and your 3, that means that the 1x has to go here. And it's, I apologize, it's a -2. All right. If you get confused what goes where, remember, a is 2x squared. So when you break a into 2 and 1, they both need an x to get 2x squared. Really, this is like kind of like a 2x and a 1x. That's a 2x squared. So the 2 and the 1, oops, the 2 and the 1 are the x squared ones in green. And the 3 and the -4 happen, or the 3 and the -2 happen here. Those are just the constants. Okay. In the effort to save time on this video, I want you to try this example here, and this example here in both methods. I will, again, post the notes on them, but in an effort to save time on this video, let's have you do that on your own. Moving on to this last example, feel free to pause here and do those other ones, but I'm going to do this example now. Sometimes we have to factor out a common factor if possible. Look at these. This did not have a common factor. There was a 2 here, a 2 here, but no 2 here. Okay. This one, there was a 6 and a 3, but no 3s there, right? This one, there's a 2, a 1, and a 21. Well, that's a mess. This one's a 10, a 17, a 3. Nothing in common. But let's take a look at this one. Our example 1, which is why I left it to the end, is because this has a 3, this has a 3, and this has a 3. Also, looks like that has an x, that has an x, and that has an x. So let's pull out what we know, which they all have 3x, and leave what's left over. Well, looks like there's an x squared left over. Looks like there's after I'm done factoring out a 3, I have a 5 and an x left over, and a 6. So here in this case, a 3x times x squared is 3x cubed. A 3 times a 5 is 15, and an x times an x is a 15x squared. And then a 3x times a -6 is a -18x. And here, we're ready to factor by grouping, except we don't necessarily need to factor by grouping. We don't need grouping. I don't know what just happened. We do not need grouping if a is equal to 1. So see how a is equal to 1 right here? We don't need it. We can definitely do it, but it's not going to matter. So let's show you what it looks like. Let's ignore the 3x for now. Let's just take x squared plus 5x minus 6. We'll put the 3x back there later. If we do a times c, we do a times c, we do 1. A times c is 1 times -6. So we get -6. Well, the factors of -6 that add up to 5 are going to be 6 and 1. All right, 6 and 1. So if you notice 6 and 1, I can do x squared plus 6x minus x minus 6, and I factor out in x, and I get x plus 6. I factor out a -1, and I get x plus 6. And finally, I factor out my x plus 6, and I have x minus 1 left over. Notice 6 and, oh, sorry, I messed this up. -1 is what I meant. Apologize, I hope that didn't mess you up. 6 times -1 gives me -6. Notice 6 and -1 are exactly what I have. So if this coefficient's a 1, you don't have to go through factor by grouping process. You can simply go directly from this step to this step. What times what gives me x? That's x times x. What gives me -6? That adds to 5. +6, -1. And you skip that step. Even if you want to do it by the fast factor by grouping, if we did it by the quick factor by grouping, you have x squared plus 5x minus 6. You still have the same a times c, and then the a is 1. So a is 1, which factors into 1 and 1, which means you divide both of these by 1, and you still have your 6x and -1. And so you have 1x, and, well, here, let me put the 6 and the -1 in place. And then these right here, your 1 and 1, are 1x and 1x. So again, you just have x plus 6 and x minus 1. You do not need to go any further by factor by grouping if this leading coefficient's 1, because 1 divided by anything is itself, bringing you back simply to the a times c. So we'll say you can skip factor by grouping. What we can't forget, though, is that this 3x is still there. So technically, it's now finish combining. Now, I don't want to use the word combining. Now finish writing. There we go. And so it's going to be 3x times x plus 6 times x minus 1. And I will duplicate that right there. And we'll put a little divider in between. There we go. Okay, and that was our last example. I'm going to let you do these on your own. You should see quickly what these have in common, 5, and what this one has in common. Alrighty, so just to summarize the factor by grouping method, so feel free to pause the video at this point and try it on your own, but I'm going to start to answer all these blank spots. So to factor a trinomial of the form ax squared plus bx plus c, we first have to find a factor pair of AC, right? We're going to multiply A times C. And after we do that, we're trying to look for what adds up to B. Remember, we do A times C, and we're looking for what sums, in this case, add or sums up to B. Okay. Now we have to take BX and we have to break it apart. And so from then, we're going to say we're going to rewrite BX as a sum of those factors. And once we do that, then remember, once we did that, we then had to factor it again. We had to factor out this, which is our greatest common factor. So we're going to say factor out the GCF. We're going to factor out this GCF, or greatest common factors, from the expression twice to factor out the original trinomial as the product of two binomials. That's what we did. We factored that GCF twice. The first time is getting out whatever we could this first time, which was taking out an x, for instance, and a -1, and then factoring out the x plus 6 one more time, and that leaves us with the x minus 1. Okay, so in this one, we would do, here's an example, a times c. So 3 times 7 is 21. 21 breaks into 21 and 1, which is 22. So we do 3x squared plus 21x plus 21x plus 1x plus 7. We factor this into 3x, x plus 7, and then we factor out a 1 and x plus 7. And then finally, we factor out the greatest common factor one more time, which is the x plus 7, which leaves us with 3x plus 1. All right, and that's our final answer for that. Now, using the quick method to quickly factor a trinomial of the form, you guessed it, ax squared plus bx plus c. First, find a factor pair of, you guessed it, ac, that has the sum of bx, or I apologize, sum of b. Then we're going to take those factors and divide the factors of blank across both factors. So we're going to then take the factors of a, and we're going to divide them across both factors that sum to b. And finally, determine the order of each of the a factors needed to be placed in their binomial pairs. Oh, actually, this should be, yeah, a factors needed to be placed in their binomial pairs to work successfully. Okay, and so for that same example, we're going to take 3x squared plus 22x plus 7, and we will do 3 times 7 is 21, which breaks into 21 and 1. That's how I get my middle term of 22. And then I take a is 3, which can be 3 and 1. The only pair that works would be 3 here and a 1 here. So that leaves me with 7 and 1. So 7 and 1 go at the end. And the 3 and the 1 have to go in the beginning, but the question is, where does the 3 go? Well, 3 has to match 7, which forces the 3 to be in the other set of pairs. In this binomial here, I apologize, in this binomial, because 3 times 7 has to multiply to get the 21, which leaves us with the 1x right here. Okay? And so there you go. To quickly factor the trinomial of the form ax plus bx plus c, ax squared plus bx plus c, find a factor pair of ac, which we did. That has a sum of b, which we did. So 21 and 1 is 22. Divide the factors of a across both factors that sum to b. So here the sum to b. Here's the factors of a. We divide them. Finally, determine the order each of the, I guess we could say, a factors and c factors, but let's just say the yeah, the a factors needed to be placed in their binomial pairs to work successfully. Here's your binomial pairs, and there you go. All right, I hope you enjoyed this lesson. Complete the rest of the work. Okay, good luck.